So this lesson is on writing an equation of a hyperbola. So we have had a circle, we have had a parabola, and we have had an ellipse. Okay? So now we have a hyperbola. I do want you to notice the hyperbola, how it takes the ellipse really and just inverts it so that your ends don't come together, they go apart. Okay? So we would kind of have the same type of equation as an ellipse. The only difference is there will be a minus in between them. For an ellipse, we had a plus between our two fractions. For a hyperbola, there's a minus because they are reflecting off of each other. They're going away from each other. So I do want you to see a couple of examples here. A hyperbola can open on the x-axis or on the y-axis, depending on which term is positive. Okay? So an ellipse, just to remind you, had a plus in between it, and the largest denominator was the widest side. Okay? For a hyperbola, there is a minus between them, and the positive term, or fraction, whichever you want to call it, determines the direction the graph opens. Okay? Now, if you look at this first example here, notice how my parabola is opening along the y-axis. So that means that when they wrote this equation, the y term was the first fraction they got to. Okay? Just so you're clear of that. Okay? We have a minus between them, but the positive term, this first term, tells you how that parabola is opening. It's opening on the y. And remember, the hyperbola is just like the ellipse in that it has to equal 1. They both have to equal 1. So if you look at the second example, you notice that my parabola is opening along the x-axis, okay? So that means the x term was first and the y term was the negative. So this would be the positive term, okay? The negative is on the negative term. All right, so we do have a center. All right, the center is equal distance from where those two parabolas are. They're calling them branches, but they kind of look like parabolas. Okay, and you also have orientation, and that would be which axis does it open on. Okay, so in this first graph, the orientation would be along the y-axis, or it will be vertical. They would call it vertical. Okay, this particular axis is called the transverse axis. This is where the graph is facing. Okay. The other axis is called the conjugate axis. You aren't usually asked about that. Don't know that if in AP Calc you'll be asked about it later, but you're never asked about the conjugate very much in pre-calculus. The main one they're talking about is the transverse axis, the one in which the parabola or the hyperbola opens along. And that transverse axis is a vertical line that goes through the vertices. Okay, you're going to probably name that x equals 0. This would be y equals 0. Okay, so whatever it goes through the center, that's going to be your transverse axis. All right. Now, the center of the hyperbola may be transformed from the origin. So if you have a transformation, of course, there's our h and our k. And remember, the h goes with the x, the k goes with the y. All right, so just be aware of that. All right, so let's just try one, okay? So we have a center, or where our graph is going to begin at 0, 0, because there was nothing added or subtracted up top in the numerator. Okay, so now the foci you will not have to be able to name. All right, conjugate axes you will not have to be able to name. Doesn't matter what it is. The asymptotes, I'll show you about those, are something you have to name. Okay, so let's just start graphing. We have a center at 0, 0. Okay, now we need to know how far are our vertices from the center, and that is being told by our denominators. All right, so if we take the square root of 9, we get 3. So along the x-axis, our vertices are 3 out. Okay? Then if you look at the y, we have a 4 in the denominator, so the square root of 4 is 2. So along the y, we're up and down 2 from the center. Now, our hyperbola must work outward. It is going to open on this positive axis, the x-axis. So our transverse axis is going to be x. Okay, and then we're going to have to tell what is that equation. All right, so what we do with the hyperbola is that we make a box using our denominators. Okay, there's my box. Our asymptotes go from corner to corner. So they are lines that go from corner to corner in this little box that we have created, and we're going to name those equations. So this is y equals, and our intercept is at 0, so we just did down 2 over 3 and we went up 2 over 3. So 2 and 3, 2/3 is our slope, but we went positive 2/3 and we went negative 2/3 x. Okay? All right, it opens along the x-axis, so our hyperbola is drawn from that vertice from our box, and we stayed within these asymptotes. Okay, now our vertices are here. That's what we're going to name. So we have one at -3, 0, and one at 3, 0. Those are our vertices, and our transverse axis goes right through the center of that parabola. So it's going to be, it's going to cross y, so it's going to be y equals 0. The axis is the x-axis, which gives us an equation of y equals 0. Okay? All right, so let's try another one. I know this is taking a little bit more time than I anticipate, but we got to get to a couple of them. All right? So our center again is at 0, 0. Do not need to worry about these two things. Oops, orientation would be good. We will look at that. Okay. All right. So from the y, we are 3 units. Square root of 9 is 3. And from the x, we're 5 units. Now, we're going to make our box with these points that we just drew on the graph. Okay. And remember, our asymptotes are corner to corner. So we're going to draw a straight line corner to corner. And you can probably do this better on your paper, okay? All right, so our asymptotes are y equals, and since our center is at 0, then we're just going to have plus and minus of whatever the slope is. So it's up 3 over 5. So that's 3/5 x. Okay? The vertices. Now, our positive term was the y. So our parabola, our hyperbola, is going to open on the y. Okay? So our vertices are here at 0, -3, and 0, 3. Our transverse axis is the y here. It's going to cross over the x. So it's going to be the y-axis. And that equation, if they ask you, is x equals 0. It's going through x. And the orientation is vertical. Okay? It opens on the y, so it's vertical. Alright, so let's look at one with translation. So we do have a movement here. Our x is a 1 and our y is a negative 1. So our center is 1, negative 1. Alright, we don't have to worry about foci. Distance on the y-axis, square root of 16 is 4. So we're 1, 2, 3, 4 above, 1, 2, 3, 4 below. And along the x, we are 2 and 2. Here's our box. Okay. And we're going from corner to corner, center to corner. So we're going up 1, 2, 3, 4 over 2. 1, 2, 3, 4 over 2. So we are going to hit this. 1, 2, 3, 4, 2. So down 2, 1, down 2, 1 is down 4, 2. Okay. This equation is going to be 2x, positive 2x, and we're crossing at negative 3, it looks like. The other asymptote is going to be a little bit different. We're going to cross at 1. Okay? So the other one is going to be y equals a negative 2x, because that slope is going down, but we're crossing at a positive 1. So that's our asymptotes. Alright, the y is our positive, so it's going to open along the y. So the y-axis is the transverse axis. And if they ask you for that equation, it's going to go right through the center. So it's going to cross x at 1 on that transverse axis. Alright, and the orientation again is vertical. Vertical. Okay. Alright, so let's try one more. This one we are going to have to complete the square with. So we're going to look at this one for our last one. I'm going to get the x terms together. And then we'll get the y terms together. And there's not anything added to that. So we really don't have to do anything but leave that negative 3 on the outside. So we're going to take our coefficient out, which gives us this for our x. And if we take that coefficient out, we get y squared. So we really don't have anything added or subtracted in here with the y's, and it equals 36. So let's complete the square. Half of 6 is 3 squared is 9. And then 9 times 2 is 18. Alright, so we're going to write this as a binomial squared. And this we'll just leave like it is because we didn't have anything there. Alright, and 36 and 18 are 54. Alright, so let's see if we can reduce this. 2 into 54 would be x minus 3 to the square over 27. And then this would be minus y squared over 18. And it would equal 1. And neither one of those worked out very good at all. Okay, so let's